Welcome to the dimensional analysis module. Dimensional analysis is basically a method we use for problem solving that uses the fact that any number or expression can be multiplied by another without changing its value. So it becomes a different unit of measure, but it's the exact same amount. So an example of that would be 1 inch is 2.54 centimeters. So to find how many centimeters there are in 5 inches, we would multiply that times 2.54 centimeters. So as we go through this module, we will work out 5 problems using dimensional analysis, and then after you will take a post-module quiz. Now we are going to get into our actual problem. So number 1 here reads that we have an order for heparin 3,000 units sub-Q 4 times a day, and it looks like the drug that we have available is 5,000 units of heparin in 0.5 mils. So the question is, how many mils of heparin would the nurse draw up in the syringe? If you would like to try to work this out on your own, I encourage you to pause the video here and take a moment to work this out on your own. So we have an order for 3,000 units, and we are going to use dimensional analysis to find how many mils we need. So if we're looking for mils, we're going to multiply times mils. It's going to be on the top. We're going to get rid of our units, so our units are going to go on the bottom. And then our units are going to cancel out. So then we have 3,000 times 0.5 divided by 5,000. As I mentioned before, I like to reduce down and get rid of some of those extra zeros. So really, this is the exact same as saying 3 times 0.5 divided by 5. And then our answer is actually going to come out to 0.3 mils. So for number 2, we have a nurse that has an order to infuse 1,000 mils of normal saline with 10 mil equivalents of potassium chloride in 480 minutes. At what rate should the nurse set the IV pump? And we are looking for mils per hour. If you would like to try to work this out on your own, I encourage you to pause the video here and take a moment to work this out on your own. The first thing I want to point out is we are looking for mils per hour. So the fact that we have normal saline with 10 mil equivalents of potassium chloride is not a factor for this problem. That's distracting information. Do not get distracted by the 10 mil equivalents of potassium chloride. That's not going to help you find your answer for this problem. It's just distracting information. The important information for this problem is the 1,000 mils, because we know we're looking for mils per hour, but we have minutes. So we have 480 minutes. So we're going to put our 1,000 mils over our time, because we know we're looking for mils over time, but we need to convert that time from minutes to hours. We are going to take 1,000 mils over 480 minutes times 60 minutes, because when we put minutes on top, it's going to cancel out, and that is going to put also our mils over our hours. Punching that in the calculator, we have 1,000 mils times 60 minutes divided by 480 minutes divided by 1 hour equals 125 mils per hour. So I like to reduce down. I'll get rid of a couple of those zeros. So then I end up having 6 and 48. And then the next thing, when we think about that, 6 goes into itself 1 time, and then it goes into 48 8 times. So we can actually reduce down a little further. So we end up with 1,000 mils divided by 8 times 1 divided by 1 equals 125 mils per hour. In problem number 3, we have a client who is MPO, that has an order for 1,500 mils of D5W and half normal saline with 30 milliequivalents of potassium to be infused over 14 hours. How many mils per hour should the IV pump be programmed for? So again, pay no attention to the D5W, the half normal saline, or the 30 milliequivalents of potassium. That's all distracting information. Another thing I want to point out is that mils over hour is actually going to be our formula for this. If you would like to try to work this out on your own, I encourage you to pause the video here. So if mils over hours is our formula, and we already have our mils and we already have our hours, we just need to put 1,500 mils over 14 hours and punch that into the calculator. What we end up with is 107.1428557. So, depending on the problem's instructions, you will either have to round to the whole number, to the 10th, or to the 100th. So you're going to look at the number next to where you're rounding. So in this case, we're going to round to the whole number. So with the 0.1, we round to 107. If it is 5 or above, so if it had been 107.5, we would have actually rounded to 108. For this problem, our answer is 107 mils per hour. Problem number 4, we have a client that is scheduled to receive cephalexin Keflex, 4 grams, in 150 mils of D5W. According to the pharmacy, the preparation should be administered over 90 minutes. Calculate the correct flow rate for this medication in mils per hour. So we're going to take our 150 mils. We know that that is going to end up on top, mils over hours. So 150 mils over our time. So right now we have 90 minutes. To get rid of our minutes, we are going to have to multiply that times 60 minutes, because there are 60 minutes in 1 hour. So our minutes cancel out. And then we can punch that into a calculator, and we get 100 mils per hour. I'm going to reduce down after the fact this time. Zeros cancel out, and then 6 and 9 are both factors of 3. So 3 goes into 6 2 times and 9 3 times, and then 150 and 3 can also both reduce down because 3 goes into 150 50 times. So then we have 50 times 2, which is also 100 mils per hour. It's a little bit of a different way of getting there, but we get the same answer either way. We are going to get into drop factor problems now. Dimensional analysis is the best way to do this problem type, but in the IV calculations made easy video that I will also recommend you watch, we'll actually create a bit of a shortcut and have a formula that goes along with that. A nurse is preparing to infuse 1,000 mils of 0.9% sodium chloride IV over 10 hours with a tubing set that delivers 20 drops per mil. The nurse should infuse the IV fluid at how many drops per minute? So we're looking for drops per minute. The way we set this up, we know that we have 1,000 mils. We know that we have 10 hours. Now we're looking for minutes, so we need to actually get rid of our hours. We do this by putting our hour on top over 60 minutes because there are 60 minutes in 1 hour and we are looking for minutes. And then we are going to multiply this by our drop factor. So we have 20 drops over every mil. So there are 20 drops per mil. Our mils cancel out, our hours cancel out. So to punch this in the calculator, we have 1,000 times 1 times 20 divided by 10 divided by 60 divided by 1. And what we end up with is 33.333 repeating drops per minute. Just like the last problem, I'm going to reduce down here at the end. So the first thing I'm going to do is 20 and 60 actually can reduce down because 20 goes into itself one time, it goes into 60 3 times. And then we can also mark out a 0 in that 10, mark out a 0 in our 1000. So now we have 100 times 1 times 1 divided by 1 divided by 3 divided by 1. An easier way to do this is to just leave out the ones, and it's 100 divided by 3, and we get the same answer, 33.33 repeating. We are going to round this to the nearest whole number because it is not possible to have a fraction of a drop. So we're going to look at that tenth. It is less than 5, so it's 3. So we're going to round to 33, and our answer is 33 drops per minute. Alright, problem number 6 is going to be our last problem. We have a physician that ordered digoxin 0.25 milligrams IV every morning. The available vial reads 0.5 milligrams in 1 ml. The nurse would administer how many mils? So we're trying to get rid of milligrams. We're going to take our ordered 0.25 milligrams. We're going to multiply that by our amount, which is 1 milliliter, over our milligrams, so they will cancel out, which is 0.5 milligrams. Our milligrams cancel out, and our answer is actually going to be 0.5 milliliters. Something that I want to point out here is it doesn't matter that this is an IV drug or that this is in mils, because you could replace the word IV with PO or by mouth every morning, and you can also replace mils with tab. So we have 1 tab that is 5 milligrams. The order is for 0.25 milligrams. And our answer is still going to be 0.5. It's just going to be 0.5 tabs now. So don't get freaked out just because you see something as IV. Thank you for watching the Dimensional Analysis module video. At this time I will ask you to take your post-module quiz, and I want to wish you the best of luck in nursing school.